Today there are only two species of camel left, the dromedary and the Bactrian. The Bactrian has two humps, dromedary has one, and these two animals can hybridize, which usually leads to a larger offspring. Now, they can hybridize so easily because they last shared a common ancestor just around 400,000 years ago. However, the story of their hybridization got a lot more interesting as a team just published the genome of an extinct camelid that was much larger than either of these two. These were the first paleogenomes from this extinct species, and they revealed a lot more hybridization in the camelus groups than we realized, including hybridization with this giant species and the modern day lineages. On this phylogenetic tree, like these animals up here are the camels, the modern camels, and this extinct one. This one over here, this is Lamini. So this is the group of animals that's like camelids, but not true camels, like the alpaca, the llama, and their ancestors. While the camels we were talking about today, the modern ones, diverged from a common ancestor around 400,000 years ago, making their hybridization really easy to understand. When we look at this group that includes alpacas and llamas, they had a last common ancestor with the rest of these organisms around 16 million years ago. And you know what? They can also hybridize. This is a cama, the offspring between a llama and a camel. The goal was to create a larger animal that would produce wool like a llama. It was relatively unsuccessful. There's a reason we're not making them often anymore. But again, it's a cool connection, not only about like hybrids and how inconsistent hybridization can be, but it's a connection between the Americas and Eurasia, because these camels, the camelids, they originated over in North America. The llamas and alpacas and their ancestors, they migrated into South America from North America. Other camels, they migrated out north. They continued living out in Eurasia, while all of ours in North America ended up extinct.